I welcome you all to this live session. I would request you all to post your question if you have any in the chat box so that we can start, our discussion. Learners, students who have enrolled with this course, I request you all to post your question in the chat box if you have any, so that we can start our discussion. You know that in this course, I have discussed about the steam power cycle part. And if you have any specific question from this module of this course, I can now discuss. I request to post your question in the chat box. Students, learners who are attending this live session, I request you all to post your question in the chat box so that we can start our discussion now. You know that I have discussed about the steam power cycle of this particular course. So any specific questions from this module, if you have any, I request you to post in the chat box. I have discussed about the steam power cycle, wherein we have discussed about several, cycles. Also, we have discussed about steam turbine. So any questions, any doubt you have from this part of this course, we can discuss them now. I request you all who are attending this live session to post your question in the chat box. Mohammad Akhil, you are telling me the assignment number 7, question number 10. I request you to post your question here. So it would be nice if you can specify the question, and let me see if the question is coming from the part which I have discussed. I would be happy to give you answer. Only questions from the steam power cycle, that means the module that I have discussed in MOOCs platform. If you have any questions from this module, I request you to write your question here so that we can discuss. Learners, students who are attending this session, I request you all to post your question in the chat box. If you have any specific questions from this steam power cycle part of this course, I have discussed the steam power cycle part of this course. So any specific question from this module will be discussed in today's forum. I request you all to post your question in the chat box. There are several other modules of this course. My colleague and co-instructor of this course will join the session soon, and he also would like to discuss questions. But if you have any questions from the steam power module of this course, kindly post your question in the chat box. So it would be nice if you post your question in the chat box. Let me see if the question is from the steam power module of this course. I would be happy to discuss here. If the question is from other modules of this course, you need to wait a little more so that my co-instructor will join and he will discuss. For the steam power cycle, if I can recall, I have discussed about the Rankine cycle, its modifications, and also the steam turbine part. We have solved a few numerical problems. Any specific queries if you have from this module, I would be happy to discuss them now. So I request you all to post your questions here in the chat box. Dear learners, students who are attending this session, I request you all to post your questions if you have any from steam power cycle part of this course so that we can discuss them now. You know that in this particular course, there are several modules. I have discussed about the steam power cycle part. So if you have any questions from that part, I would be happy to discuss now. Any specific questions from the steam power cycle part, wherein I have discussed about several cycles, their modifications. We have solved a few numerical problems, and we have also discussed about steam turbine. So any questions from this part, if you have, you can post in the chat box. I have discussed about Rankine cycle, its modification, which are important to increase the efficiency of the Rankine cycle. Then we have talked about, steam turbine. We have solved a few numerical problems. We have also discussed about boilers. So any questions from this module, if you have, you can post in the chat box and we can discuss them now. We have solved a few numerical problems from steam power cycles. We have solved problem on steam generator. So we have also solved problem on steam turbine after having a thorough discussion on the theoretical part of these components. So if you have any questions from these components, that is their operational principle, we can discuss them now. I request you all to post your question in the chat box. Learners and students who are attending this session today, and if you have any specific questions from the steam power module of this course, kindly post your question in the chat box. Yes, so Mr. Mahmoud Akil, I again request you to write your question in detail so that I can read the question and I can tell you. Let me see whether this question is coming from the module which I taught for this course. If this question belongs to other modules, then you have to wait a little more so that my colleague, when he will join this session, he will interact with you. We have discussed about Rankine cycle, which is used to measure the performance of a steam power cycle, steam power plant. And then we have seen that there are several modifications of the simple Rankine cycle, essentially to increase the thermal efficiency of a steam power plant. We have discussed all those aspects. Then we have solved a few numerical problems. We have also discussed about the steam generators. I mean, if I can recall, we have discussed about both fire tube and water tube steam generators, and we have discussed about their operational principle. Finally, we have also solved one numerical problem on steam generated. And we have discussed about steam turbines, both impulse and reaction. And we have discussed about the important aspects of steam turbines from its operational perspective. So any questions if you have from these components from these modules, from this particular module, I request you all to post your question in the chat box. So this particular module of this course is very important because you will find the practical application of this particular module. And we have discussed about the theoretical aspects. We have also discussed about the design aspects of several components which are there in a steam power plant. And we have also discussed about the steam generator, discussing about the operational principle of steam generator. So any specific questions from this module, if you have, I would be happy to discuss now. If we talk about Rankine cycle, then you can understand several processes, and those processes are there in a steam power plant. Considering more practicality, we have discussed about the modifications of simple Rankine cycle, essentially to get better thermal efficiency. So to this end, we have discussed about increasing boiler pressure, reducing condenser pressure, and superheating the steam. So all these three modifications we have discussed in the context of the simple Rankine cycle. We have seen in all these cases, thermal efficiency can be increased, but at the cost of getting such an enhanced thermal efficiency, there are several other issues. And if we need to address those issues, again, we need to think, for, improvement or better improvement of the cycle. And we have also discussed about regenerative Rankine cycle, wherein we had seen that regeneration by extracting steam from turbine at an intermediate state and allowing feed water to the boiler to get mixed with that steam, either in a direct type or in an indirect type, can enhance the thermal efficiency of the cycle. We have also solved numerical problems from this part, and then we have discussed about steam generator, steam turbines, condenser. So any questions if you have from this module of this course, I request you all to post your question in the chat box. Dear learners, students who are attending this session, and if you have any specific question from the steam power cycle of this course, you may post them now in the chat box. I would be happy to discuss all these questions in this forum. Mr. Lovely Ahmed, you are asking one question that with increase in the speed of SI engine, the crank angle required for flame propagation is affected. Is false? How, please? I would like to ask you to wait a few more minutes, because this question, what you are asking is from the ice engine part or ice engine module of this course. My colleague and co-instructor of this course will join soon, and he will discuss this question. He will give answer to this question. So I request you to wait few minutes more so that you can get answer of this question from my colleague and co-instructor of this course. Any specific questions, if you have any, from the steam power module of this course, I would be happy to discuss them now. You may post those questions in the chat box, be it from the cycle, be it from the operational principle of any particular component or device. Those are there in a steam power plant. We have discussed about steam generator. We have discussed about steam turbine. We have also discussed about condenser. So any specific question from this particular module, be it from the power cycle, or it may be from the operational principle of any particular component, I request the participants, learners who are attending this session to post them in the chat box. Learners, we have discussed about the Rankine cycle. We have also discussed the Carnot cycle, and we had discussed that thermal efficiency would be 100% if we use Carnot cycle. But at the same time, we have also discussed about the practical issues of implementing the processes using Carnot cycle. And then we have discussed about the simple ideal Rankine cycle, and again identifying the issues involved with this cycle. We have discussed about several modifications. So any questions if you have from this module of this course, I request you all to post your question in the chat box. I can see there is no question in the chat box, but still, if there is any question from this particular module of this course, you may post them in the chat box so that we can interact now. The question may be from the steam power cycles. It also may be from the operation of any particular component, those we have discussed in this module, like steam generator, steam turbine, and condenser. So if you have any question, you can post them now in the chat box. Questions related to internal combustion engine will be discussed by my colleague and co-instructor of this course. So I request you to wait a little more so that when my co-instructor will join the session, he will discuss. Any questions from steam power module of this course? If you have, kindly post them in the chat box. When we have discussed about steam power cycle, we have discussed about the thermodynamical aspects, as well as we have also discussed about several aspects related to fluid mechanics, heat transfer. So in the context of this module, even if you have any questions from the basics, you can post that question in the chat box so that we can interact. learners and students who are attending this session. And if you have any specific questions from the steam power module of this course, you can post them in the chat box so that we can discuss. We have also solved a few numerical problems in the class. So any question related to the numerical problem, related to the operational principle of mechanical components which are there in a steam power plant, also any questions related to the power cycle, if you have, kindly post them in the chat box so that we can discuss them now. Yes, Mr. Boss, you are asking two questions, and these two questions are from internal combustion engines. So I request you to wait a little more, and my colleague will join this session soon. And during that time, you can interact with my colleague to get answer of these questions. So I request you to wait a little more. Let me tell you once again, I have discussed about the basic cycle. I have discussed about modifications of steam power cycle, that is simple ideal Rankine cycle, essentially for the improvement of thermal performance of steam power plant. Afterwards, we have discussed about the operational principle of steam generators, steam turbine, and finally condenser. So any specific questions from this module, if you have, kindly post them in the chat box so that we can discuss them now. Interaction of these questions with you may help the other learners who are attending the session. So if anyone is having any question on this module, kindly post that question in the chat box. Yeah, I can understand that you have only one question, but it is in two parts. But I request you to kindly wait a little more so that my colleague can interact with you. My colleague will join soon this session, so please wait a few minutes more. So what I can see, that there is no question anymore. So I would like to log out from this session and my colleague will join this session. Thank you.
Very good afternoon. Welcome to this live session. Now, first of all, before I take up these questions which are there in the chat box, uh, uh, let me share some of the questions that were raised in the discussion forum during last 1 month. So the first question was raised in the discussion forum is the formula for C6H13 is called isocetane. I don't think it is the right interpretation. If you look at my lectures on this particular topics, so what the idea is that you need to find the certain number of a given fuel. And one thing that to find this one particular certain fuel is given a certain value of 100, and that is known as N-cetane, or it's nothing but hexadecane. Its molecular formula is C16H34, while the which is for the other side, which is not particularly used for diesel fuel, then its certain value was assigned as 15, and that is nothing but your heptamethyl nonane. So this is short form, we call this as HMN. So its formula is C12H34. So here your question was HMN is not HMN does not have the chemical formula C16H13. HMN has the chemical formula of C12H34. And but the isocetane is not the right word. It is used as N-cetane, and that is nothing but C16H34, and it is called as hexadecane. By doing so, the actual cetane number of the fuel was calculated by using the formula percentage of N-cetane plus 0.15 times percentage of HMN. The second question was related to one of the lecture, that is for this question of IC engines, where there is a 4-cylinder engine, 2.5 liter, and it is basically the thermodynamic analysis of a SI engines. And this problem, this is lecture number 25 of numerical problem 1. So while revisiting its answer, we found that the query raised by the candidate is correct, and the actual value, correct value, is 3956 Kelvin. Okay, the third questions, what was raised for the lecture number 27. The question was, in an SI engines, isooctane is burnt with 115% theoretical air, and we need to do an equivalence ratio. And this the stoichiometric reactions is given by C8H18 plus 12.5O2 plus 12.5 into 3.76 N2. That gives rise to 8CO2 9H2O plus 12.5 times 3.76 N2. So this is the stoichiometric reactions. Okay, so the exact answer which was solved actually in the lecture is given by this, but the queries that is raised by the candidates is the calculating the fuel air ratio value. So the problem that lies here, that here while taking this value, there is a multiplying factor 4.46, and it has to be multiplied in the mass of air. Why? Because if you take air, it is air molecular weight. Air molecular weight is 29. Okay, and it's and this its stoichiometric coefficient or number of moles is 14.375. Okay, and that 14.375 has to be, when I take 14.375 common, and we need to find out N2 and O2 consists of air. So 3.76 plus 1 will be 4.46. 4.76. So that is will be a multiplying factor 4.76. So I have written my mistake is 4.46. So while solving the questions, what you need to do while calculating air fuel ratio, we need to find Ma, that is equal to number of moles into molecular weight. So and Na, that is number of moles, is 14.375, and that has to be multiplied by 4.76. Then you multiply mass of the air. So wherever this calculation is, that if you do it, you will get 17.4 as air fuel ratio. And similarly, while calculating the fuel air ratio, and here also, while the MA stands at the denominator, and there also we have to multiply 4.76 times molecular weight of air and number of moles. So I think that that was a mistake. I mean, I should have mentioned, but anyway, it should be 4.76, not 4.46. Okay. 3.76 coefficient is associated with nitrogen. That is because if you look at the composition of air, and in our engine we say fuel air mixtures, and air majority times air is consist of nitrogen and oxygens. Their ratio is ratio in terms of number of moles is 3.76. So here air fuel ratio, okay. How do you get? No, when you say air fuel plus 1, it is mm. That is not correct. I think air fuel ratio is a non-dimensional number. I mean, a number, but it's a mass. So it is not correct. So rather it should be mass of mixture divided by mass of air. The next question is to find out the formula for question 23, heat addition process in Otto cycle. So when you look at the heat addition process in the Otto cycle, please refer the numerical problems that was discussed in the lecture number 26. So there, and the link is there, that you can find out how the heat addition process was explained very nicely in this lecture. Here, one very common questions that was raised by this learner, that is, why do you divide as crank angle by 360 in the formula? Because one thing that I need to mention, that 360 means one rotation. One engine rotation, suppose I say revolutions per minute. So it is one rotations. But whereas when you talk about ignition timing, exhaust valve opening, inlet valve opening, all these things you calculate, the angle was calculated with respect to TDC or BDC. So TDC stands for 0 degree, then another one will be 360, then another one will be 720. So you start from here TDC, and again we'll reach TDC after 360 degree. Then again we'll reach TDC at again 360 degree. So one circular rotation gives 360 degree. But while calculating valve opening, we refer the value with respect to TDC or BDC. So that is referred BTDC or ATDC in this form. Now, while talking about crank speed or engine speed or RPM, we say revolutions per minute. So that is the reason it has to be multiplied by 360 in this formula. The next question that comes here, what happens in the dissociation process of the combustion engine? Does temperature increase or decrease? So it is an endothermic process, because during a dissociation process, some amount of heat is absorbed. That process is endothermic. So during dissociation process, the actual temperature that was supposed to be, it is less than that of the maximum temperature, because some of the energy is likely to get utilized for the dissociation process. Okay, so these are the questions that was raised by learners. Now I think now uh, so there were some queries in the chat box. First question is Lovely Ahmad. What is to be answered is that with increase in the speed of the engine, the crank angle required for the flame propagation is affected. Is false. Okay. So the the point that I need to mention is that uh, the when you are looking at the engine combustion in spark ignition engines, there are three different zones: flame generations, flame propagation, and flame terminations. And during this point of time, during the initial phase, only 5 to 10% of the fuel is gets consumed, and most of the things is consumed during the flame propagation phase. So that is the reason that the flame propagation gets affected when you increase the speed. So when you increase the speed, essentially we are loading the fuel air mixture into the engine. The next question is that spark plug is fired 18 degree BTTC in the engine running and 1800 RPM. So it takes 8-degree engine rotation to start the combustion into flame propagation mode. The flame termination occurs at 12-degree at TDC. Engine bore diameter, spark plug offset, everything is given. We need to calculate the flame speed. So I think here I should emphasize that this particular problem is exactly solved in one of the numerical problems of these things. I advise the learners to go and see that video, or you can also go through the notes material or handwritten handouts for to solve the problems on his own. So isentropic is efficiency defined in this. Okay. Isentropic efficiency is normally defined with respect to temperature rise, whereas RAM efficiency is defined with respect to pressure rise. So in fact, I have explained this particular problem in this class as well. I hope there are no other questions. If you have any other questions, please raise them. We have hardly another 10 minutes time. Dear learners, please raise the question. Within another 2 minutes, we are going to close. Please raise your questions. Where you use the Rankine cycle. Normally, Rankine cycle is used in the steam power plant. Few words. First of all, Rankine cycle is a modified cycle with respect to Carnot engines, and it is mainly used for steam power plants. And what does this cycle do? That now a steam power plant operates between two pressure range. One is boiler pressure, other is condenser pressure. The boiler pressure is at higher pressure and condenser pressure is at lower pressures. And during the heat addition process in the boiler, the water is heated from its liquid state and it goes to superheated state. So through this process, water changes its temperature from liquid to saturated liquid. Subsequently, it goes from saturated liquid to saturated vapor, then from saturated vapor to superheated vapor. Now and this is what happens in the boiler, which is called as heat addition process. And once the steam, when it is a superheated vapor, we call it as a steam at this superheated state. Then the steam at that state enters into a turbine where it expands. And during this process, we get the actual power. That means entire energy which is associated with the stream, it gets released during the expansion process. And once it done, we get the power output from the turbine. Now, after that, the steam loses its quality and it comes down to the condenser pressure. And again, the steam comes back to saturated liquid state by releasing its latent heat of condensation in a condenser. Then the fresh water is again, after reaching this, when it becomes water, and after that a pump is used to increase the pressure from condenser pressure to the boiler pressure. So this is the entire cyclic process that happens in a Rankine cycle of a steam power plant. If there are any other questions, please raise. I hope I have answered all your queries, and still I suggest you to go through these videos and handouts which are available in the MOOCs platform, NPTEL platform, and try to read in multiple times so that you will get the complete understanding. This is the sincere advice if you want to go for the final exam of this course, which is scheduled towards the end of October. If there are no questions, let us close the sessions. Thank you for your attentions. Have a nice time and best wishes for the subsequent lectures and the final exams. Thank you.